Howdy y'all, today we're doing sinusoidal functions as mathematical models day 1. And we're going to be solving this Ferris wheel problem. Now I'm going to give you a moment to go ahead and collect your papers. This is a 2-page or 1-page front and back document. And also you're going to want your calculator. And we'll get to the calculator part here in a bit. So why don't we go ahead and read the problem. We know that we're at the Texas State Fair and we're at the Texas Star Ferris wheel. And we're going to ride the Ferris wheel because it's a big attraction. And according to the official guide of the State Fair of Texas, we have some information about this so-called Ferris wheel. And we know the diameter of the Ferris wheel is 212 feet tall, or 212 feet. It takes us 82 seconds to make one complete revolution, or we know that that 82 seconds is going to be our period. So 82 seconds is going to be our period for this Ferris wheel. And because we're math folks, we figured this out. And one other piece of useful information, I'm sorry, I'm going to be losing my little cursor here all video long. So if you see that, that's just me. Is we know that the Ferris wheel is 8 feet off the ground. Now, this is a pretty nice piece of information, just for the fact that when you hit the bottom, you don't want your feet dragging on the ground, and that can be, I would imagine that would be scary. Many people would probably not have feet. Okay, now back on track. We have a stopwatch with us because once again we love math and we carry our stopwatches everywhere. Well, then again, everyone does. I'm sure all our phones have stopwatches, and we notice that once we hit the stopwatch, we have to wait for people to get on. But at 50 seconds, we're at the top of this Ferris wheel, and that'll come into play here in a minute. Now, what's going on? Oh, there we go. Why don't we go ahead and answer some questions about this Ferris wheel? And guys, I want you to attack this problem or these questions with some common sense, or some mathematical common sense. So, how high is the top of this Texas Star? Well, I first off know that I am 8 feet off the ground at the bottom. So I'm going to go ahead and just draw a circle here. So I know that here's the ground, and the distance between here and here is 8 feet. I also know that the diameter of my Ferris wheel is 212. So 8 feet plus 212, and once again I've lost out. There we go. 8 feet plus 212 feet is going to give me a total height at the very tippity top of 220 feet. Now, we're going to call this is also known as the crest. And for us cosine people, this is a very important number. Okay, so let's move on to question 2. What time will your stopwatch read when we get back down to the bottom? Well, going back over here to my picture, I know that for one complete revolution, so one complete revolution, this time is going to take us 82 seconds. That's the period of our function. So to go halfway down, or to get to the bottom, or the trough, as I often call it, would be half of that, or 41 seconds. So half of 82 is 41. If you don't believe me, pull out that calculator and type it in. And okay, so but we noticed that when at 50 seconds we were at the top, so 50 seconds has already gone by. Boy, how does time fly! And then I add the 41 seconds, or half of the period, to get that I am at the bottom for the first, or for presumably the second time. But I am, after this rotation, it is 91 seconds. Okay, and let's go ahead and go down to question 3, and how much elapsed time will it take to reach the top of the Texas Star for the second time? Pardon my reading abilities. Okay, that means that I was at 50 seconds for the first time, and I made one complete revolution. So it was my second time at the top, and one complete revolution, or one period, was 82 seconds. So I add these two numbers together, and I get 132 seconds. And let's see. Okay, now these first 3 questions, pretty good. So why don't we go on to number 4? Number 4 is going to ask us to draw a sinusoidal graph of this situation. So let's go ahead and get there's our pretty coordinate system, and let's start labeling some key points. Now, earlier I noticed that I had a crest, so I know that the tippity top is 220, and I know at the very bottom I am 8 feet off the ground. Okay, so and then I first realized I was at the top here at 50 seconds, and look at me, I need to label my axes. We're going to call the horizontal or the x-axis seconds, or time. We'll call it time in seconds. So we'll say time, that's measured in seconds. And our vertical axis, or our y-axis, we're going to call this distance from the ground, or I'm just going to call it distance. And we measured this in feet. Okay, so once again, I know at 50 seconds I was at the very top, so I'm going to put a point here. And then at 91 seconds, which I guess we'll call right here, I was at the very bottom. Or, well, not the very bottom. My feet were not dragging on the ground. They were 8 feet above the ground, thankfully. And then, as according to question 3, at 132 seconds, I was up at the top. So then I'm going to go ahead and connect this with a smiley face. Oops, smiley face. There we go. And that looks like a cosine. Look at that. Okay, so why don't we go ahead and go on to question 5. Okay, for question 5 it says write an equation of the sinusoid. Well, why don't we figure out some useful information about the sinusoid before we go jumping off. And so for the first part, let me find my cursor once again. There we go. Why don't we find the sinusoidal axis, or the midline, as you've often heard me call it. And like we did last week, the midline we can find by adding the peak 220, that's 220, not 222, plus the trough, or 8, and dividing by 2. And when we do this, we get a distance of 114. So this midline is 114 feet. Okay, and I'm also going to notice that the distance between 50 and 100 and that was pretty, and 132 was 82 seconds, or my period. Okay. So why don't we scroll back down to number 5, and we're going to label some key aspects of when we make this, or we're going to write this equation from our graph. Now, I know that the distance between my midline at 114 and the peak was 106. So my amplitude is 106. I know that my period was equal to 82 seconds. And to get my constant b, I know I take 2 pi and I divide by the period of 82. And this gives me a constant b of pi over 41. Now, guys, you could also do this in degrees, and this 2 pi up here would just be a 360, and you would do the appropriate cancellation. But I'm going to work in degrees. So, once again, this would be a great time to pull out your calculator and make sure that it's in radians. And let me correct myself because I misspoke earlier. I'm doing this calculation in radians, so my calculator will be in radians. Now, I also realize that I have a vertical shift of 114 up. Now, I took this because this was what my midline was, or my sinusoidal axis, which I got from adding the peak and the trough and dividing by 2. And then I have a horizontal shift, which I'm going to call HOR, of 50 seconds right. Seconds right. Okay, from these tidbits of information, I can go ahead and write my equation. Now I'm going to do this in a cosine because I'm feeling like a cosine mood, and that's kind of what the graph looked like in my opinion at least. So we're going to start off with our vertical shift of 114 plus my amplitude of 106 times the cosine of our constant b, so pi over 41, open parentheses, x minus 50. Now, go ahead and pull out your graphing calculators, your TI-84s or 83s, and go ahead and type this into a y equals on your graph. Now, fortunately, I do not have a fancy application like Mr. G does where I can show you how to do this, so I'm going to trust the fact that we can graph with our 84s. So I'll give you a minute. Okay, and now we're back. So using our equation in 5, we're going to predict what our height is at certain time intervals. Now we can do this one of two ways, or we can do this one of three ways. We can either type out the function each time for our time intervals, and actually I'm going to rewrite this real fast as distance from the ground is equal to 114 plus 106 cosine of pi over 41 p minus 50. I just changed my variables to d and t. Okay. And find my cursor again, all the way over there. Here it is. So we're going to do 114 plus 106 cosine of pi over 41 of 15 minus 50. And when we type that into our calculators, making sure once again that we are in radians, we get that this is 32.222. And once again, we have 3 decimal places because in pre-cal we use 3 decimal places. Now that's one way of solving this. The next way of solving this is because we've typed this function into our calculator, we can go to the table and we can ask the table, pretty please, what is my value when the t equals 75? So you'll type that into your calculator, and you'll type in 75, and across there you're gonna get the value. Let me go ahead and do it. So, second graph would be what we're looking for, and once again we have to make sure our table set, which would be second window, is on ask for our independent. So we're going to type in 75 seconds, and we get a y value or a t value of 78.17. And because I had to look at my calculator, I lost where my cursor was. It's all the way up there. Okay. And so our height is at 78.17. We'll make that 5 and 8. 78.17 feet. And the last thing we can do is we can go to the actual graph. Now, for the actual graph, you're going to want to set up your window, and I'm going to read you what my window says. I have my x-min at -10, x-max at 40, x-scale as SCL at 100, y-min at -10, y-max at 250, and my y-scale at 10. And my x-res is always 1. So we can go to the graph and actually graph it. So we're going to go to the graph, and we're going to graph this function. Then you're going to hit the trace button, and you're just going to type in, oh wait, real fast. This was 5 minutes. My x-axis is in seconds, so I got to do 5 times 60, which is equal to 300 seconds. I'm going to type in 300, and it's going to tell me that my y value, or my distance from the ground, is 215.060 feet. That's in feet. Okay, last question. Not last question, I'm sorry. Number 7. What looks to be the last question. Okay. How high were you when we started our stopwatch? Well, when we started our stopwatch was at 0. So we're going to look at our graph, and we're going to look over towards the y-axis. We're going to ask our graph, once again using the trace function, what we were at 0. And when we were at 0, we noticed that we were at 32.222. That was our height. And were you moving up or were we moving down? Well, if we type in 1 or 1 second later, we notice that we get 27.299, but we were moving down. So we were at 32.222, and we were moving down. Okay. Question 8. What is the value of t the second time we were 100 feet off the ground? Now, for this, we're going to go back to our y equals, and we're going to plot the line y equals 100 in our second little line slot, or y2. And once we go there, you're going to go to graph once again, and it's going to graph both of the functions, and then it's going to be second trace or calc, and we're going to calculate the intersect, and you're going to scroll all the way over to the second intersection. So it hits it once, it hits it twice, you'll tell it first curve, second curve, and then you'll do an educated guess near the second point. And we're gonna get that it intersects when x is equal to 72.229. Or it's also t, because we rewrote the equation, if you remember, as d is equal to some function of t. So this will be 72.229 seconds. That was the number of seconds it took us to get 100 feet off the ground the second time. And actually, if you notice at the graph, it will be going down afterwards. Okay, last question. This time it's the last question. What is the value of t the fifth time we reach 175 feet off the ground? Well, this is a lot like question number 8. So all you're going to do is you're going to graph y is equal to 175. And guys, you know what? I'm going to let you do this one. So when you walk in the door tomorrow or on Friday, you're going to tell me what the time was. Or once we get into class, I'll ask you what the time was. So guys, have a great evening, and I'll see you in class on Friday. Yeah, bye.